stuff, but this is pretty easy. So this is vertical shifts on a graph. So if I take my parent function, we'll do this guy, Mr. Absolute Value, that we just learned about. Okay, and he looks like this. He's the V. Okay, and if I want to add something to him on the outside, so if I go like this, if I take the absolute value and I add 3, and you can put it in the calculator just to see what happens here, because I always think that's important. So we're going to put the parent in the first one, math, num, abs, x, there's your parent. For y2, we're going to put math, num, abs again. And then we're going to move our cursor over and put +3. And watch what happens here. So this blue line is your parent. That's y equals absolute value of x. And then the red line, what just happened to the function? Well, it just went up 1, 2, 3 units. And that's a vertical shift. So if you take any function, f of x, any of those functions that we just identified in the last lesson, this evening, and you add, we'll say, c units to it, you're going to go up c. So I went 1, 2, 3. I literally shifted my y equals absolute x up. Well, what if I decided to go, okay, well, take the absolute value now and -2. What do you think logically is going to happen? Well, now, again, if this is your original parent function, you're going to now go down 2. So y equals f of x minus c means you go down c units. Okay, so when you have a vertical shift, you are on the outside of the parent function. Keep that in mind. When you're outside the parent, you go up or down. That number on the outside goes up or down, outside of the parent. Well, what if I move that number and I put it on the inside next to the parent? Well, then you have a different shift. You have what's called a horizontal shift. So let's take y equals x cubed. Okay, so y equals x cubed looks like this. Starts down, goes through the middle, and curves back up. Well, what if I did x minus 2 in parentheses and cube it? So it's still a cubic function. I'm still cubing x, but I'm putting a -2 inside of it. So let's see what happens there. So again, I'm going to put the parent on y1, so x cubed. And then here, I'm going to put parentheses x minus 2 cubed. And let's hit graph and see what happens. There's the parent. I'm sorry, my calculator is so slow. There we go. Oh, look at that. It moved to the right. It moved to the right. How many spots? 2 spots. So it went like that. over 2. So here's a little general rule. If you have the f parent of x minus c, you go to the right c. Now this seems backwards to me because when I see a minus, I always want to think left. So sometimes I tell my students, when you're with your parent, you always want to do the opposite. So think opposite here. You go to the right C. You always want to do the opposite of what they say. I don't care what you say. So f of x minus c, if you're subtracting inside the parent, you go to the right. What happens then if you add? If I had something like y equals x plus 3 cubed. So again, parent function, what do you think is going to happen? I'll type it here since we already have it listed up here. X plus 3. So again, here's my parent. And look at that. 1, 2, 3 spots it moved to the left. Y equals f of x plus c. This time you go to the left c. So inside the parent, write this down. When you are inside next to that parent function, you go to the left or to the right. Usually you do the opposite of what you think. That's how I have to remember it because again, like I said, every time I see a minus, I want to go left, but when you're inside the parent, you go to the right. Okay, so then here's how homework is going to be. It's kind of neat. It's going to ask you to like describe the translation. And these are called translations. They're transformations, but when you translate, you slide and shift the graph. So describe the translation and sketch it. And I know you have a calculator for this, but you know, try to do it without a calculator. That's the whole point. You're trying to learn how to do things without it. Y equals x plus 2 squared minus 6. And then part B will do y equals square root of x minus 2 plus 3. Okay, so this is where you are going to become so masterful at this. So this is a squaring function. All squaring functions are parabolas. We know that. Okay. Outside of the function itself, outside of the squaring function, remember, its parent would be this, y equals x squared. So if I'm on the outside right here, this guy is telling me to go up or down. Well, if it's minus 6, you would go down 6. This guy inside the parent, you do what I would say is the opposite, left or right. So here I want to say, oh, plus 2 means right. Nope, nope, go left 2. So then when I go to graph this, or if I look at the multiple choice for it, that's really your starting point. Go down 6, 1, 2, 3, 4, 5, 6. Go left 2. And at that point right there would be, again, where the parent would be a parabola, like that. So that point there is the vertex of that parabola. And obviously you can put this in your calculator just to double check, but that's what's going to happen. It's going to go down 6, left 2. Pretty neat. That's why knowing all those parent functions from the first lesson is really important. Okay. This one, what's its parent function? It's the square root one. So if you remember that square root function from the first lesson, it kind of shoots off to the right. So what is this number on the outside? That's where I always start. If I'm plus 3, I go up 3. I stay the same. But if I'm on the inside of the parent, that guy is going to do the opposite of what I would want to do. I don't want to minus 2. I want to go to the right 2. So again, if I'm graphing this one, and you'll have multiple choice to see about it, but that would be your starting point. So you would go to the right 2 and then up 3, put a dot, and then it shifts over like that. The original would be here, remember, like that. I should have darkened it. This is the one you want. That's your answer right there, but that would be the original. Should have made it dashed. There we go. So pretty neat. That's the first part. That's what your homework will be like for that section. Then it's going to ask you to write an equation for dot, dot, dot. And I'll give you 3 examples like this. The square root function shifted up 5. Then write an equation for the absolute value function shifted left 2. And we'll do one more. The cube of x shifted right 1 and down 2. So let's do these. The square root function that's been shifted up 5. So remember, up and down is on the outside of the parent. So the parent is square root. So y equals square root of x, and then you just want to go up 5 plus 5. Done. Don't let that 5 be under, because remember, then you would go left and right. Make sure that plus 5 is on the outside. That's the square root function shifted up. What about the absolute value function shifted left? Shifted left. So that would be y equals absolute value of x, but I'm shifting left, meaning I have to be inside the parent next to him. So it'd be the absolute value of x, but this 2 would have to go left. And I want to write minus, but I always do the opposite. So plus when I'm inside the parent. And again, you can double check this. You can put it in your calculator and you'll be like, oh, I can't remember. Is it plus 2? Is it minus 2? Just put it in and see what happens to the graph. And it should become familiar the more you do. The cube of x, now we're doing a double shift. We're shifting right 1, down 2. Cube of x. So cube of x, again, this is the original parent. But we have to put some shifts inside of it. So we might have to add some parentheses and whatnot. So the down part would be on the outside. So I'll start there. Y equals something cubed. If I'm down 2, I would put minus 2 on the outside. And then if I'm right 1, what would go right here? Right 1 would be minus 1. Remember, you do the opposite. So this right here would be the cube 1. That goes down 1, down 2, excuse me, right 1. So you'll have a couple of questions like that. And then last but not least, oh, look at that. We're done after these next 3 examples. I told you this one was a quick, easy lesson. The other one, long. This one was not bad at all. Hopefully. Determine domain and range. Because, I mean, if you think we were done with domain and range, we are not done ever with domain and range. We will keep doing domain and range. If you don't like it, you better start loving it because it's just all over. x minus 1 squared plus 2. We're going to determine the domain and range there. Y equals x plus 1 cubed minus 2. And then I'll do one more. Y equals square root of x minus 2 and then minus 3. Okay, and this is just going to give us good practice again. By all means, you still feel a little shaky, you want to make sure you get that 100, put it in your calculator. No worries, you got infinite amount of times for your homework, but you want to get to be a point where you're like, yeah, this is not that bad. I understand this. So this is a squared function. Its parent is x squared. So you're going to do the parabola, and you're going to take that parabola up 2, and then the minus 1 inside the parent would be right 1. Up 2, right 1. So your graph would look like this. Up 2, right 1, or right 1, up 2, it doesn't matter. But right there at that dot is really where the vertex of the parabola is. So now I want you to tell me the domain and the range of a parabola. And I told you in the last lesson, the domain, and I think I told you back in chapter 1, the domain of all parabolas. This is really easy. It's awesome. The domain of all parabolas, how wide is this thing getting? It's always going to be all reals along the x-axis. All reals. How tall is this thing getting on the y? Well, it would only go from here on up on the y. And what is that y value right there? Well, that y value is 2. So 2 on up. So from 2 to infinity. And you got to use brackets here for domain and range. You don't have to on the things we just learned in the previous lesson on increasing and decreasing. Those can be open. But domain for parabolas, always, always, always infinity, negative infinity to infinity. Number 2, y equals x plus 1 cubed minus 2. So this is the cubing function. That's the one that kind of goes down, curves in the middle, and comes up. So this minus 2 means I would go down 2. This plus 1 means I would go left 1. So I'm going to make that my starting point. Left 1, down 2. And that point, again, your cubing function looks like that. The point that you just shifted is that middle. So it would go down and then up. So now if I asked you, okay, what's the domain? Again, it looks like, well, it looks like these are going straight. They're not. They're curving ever so slightly. I mean, you could keep zooming out. So your domain will always be covered for that one. What about the range? How tall is this thing getting? Well, it's gonna keep going. Negative infinity to infinity. That's the beauty of the cubic one. It's always going to do that. It's going to cover the whole entire thing. Okay. What about square root? This is our last example. Easy peasy. Okay, so square root. Remember, that's the one that y equals square root of x. That's your parent. So this minus 3 would say take that parent and move it down 3. This minus 2 would say go to the right 2. I mean, I literally have to tell myself, do the opposite every time I do that. And I've been teaching this forever. You would think by now, but it's just what happens. My brain is triggered. All right, so go to the right, 1, 2, down 3, 1, 2, 3, put a dot. So again, this square root, this dot is where it starts and then shoots off to the right. So let's talk about the domain and the range. And again, domain, how wide along the x? how wide is this thing getting along the x axis? Well, this is where it goes along the x-axis. Whatever that point is on the x-axis. What's that point? That point is 2. So from 2 to the right, from 2 to infinity, is how wide this thing is getting. Range, how tall along the y. How tall is this thing getting? Well, I don't have anything below this point on the y. And again, even though it curves and it looks like it's going to stop right here, it's going to keep going. It's going to curve ever so slightly. Again, if I keep zooming out, it'll eventually get taller and taller and taller. So its lowest bound is this y value right here, which is -3. And then it goes to positive infinity. And so that's how you determine domain and range. So that is 2.2. So all about vertical shifts and horizontal shifts and this idea of domain and range.